Hello, welcome back to AWS Solution Architect Associate. So in this module, we'll be going to this challenge lab. So here we'll be creating a VPC network environment for the Café. So let's go to this lab overview and objectives. So in this lab, we'll be creating a VPC to create a networking environment on AWS and implement security layers to protect our resources. So after completing this lab, we should be able to create a VPC environment that enables us to securely connect to a private resource that will enable our private resources to connect to the internet, create an additional layer of security in our VPC to control the traffic to and from the private resources. This is how our architecture would look like after the end of this lab. So we'll be having a lab VPC. Inside the lab VPC, we'll be having two subnets, one private subnet and the other one will be public subnet, one will be private subnet. And we'll be having one EC2 instance inside this private subnet, and we'll be having a couple of instances in this public subnet, and this public subnet will be having access to the internet, and this private subnet will be having access to this net gateway. So let's get started with challenge 1. So in this challenge 1, we'll be creating a VPC network that allows Café staff to remotely and securely administer the web application server. So task 1, creating a public subnet. So to do that, let's start our AWS. And we need to open Amazon VPC console. Let's go to VPC. So here is the VPC. So inside this VPC, if I go to VPCs, you will see couple of VPCs are already created here, and we have this lab VPC. So everything we have to do is inside this lab VPC. So let's go to subnet. So first we have to create a public subnet inside the lab VPC. Let's choose this name. Let's say create subnet. Let's choose a VPC lab VPC. So this should be public subnet. And as mentioned, availability zone should be A, US East 1A. So let's choose East 1A. And let's copy the CIDR block. So this is the CIDR block. Let's paste it here and let's create a subnet. So now we have a public subnet. So this public subnet will be having an access to internet gateway. So our next step should be to create an internet gateway. Let's create internet gateway, create internet gateway. So I can say lab IG. Let's create an internet gateway. And now I need to attach this to an VPC. So let's choose this lab VPC and attach an internet gateway. So this way our subnet which we created just now, so it still don't have access to this internet gateway. So I need to go and create a route table now. So let's go to route tables. So let's choose the route table with this lab VPC in it. So now let me just rename this. I'll say this is public route table, so we can remember this for the next time. And let's go to route and let's edit the route table. Let's say add route. It should be 000 and it should be having an access to internet gateway. Lab IG, and then let's save it. So now we have a route table, and this route table is routing all this destination to the internet gateway, and we need to add this route table to the subnet. So here we edit the route table and we create a VPC, add the route for the target, select the internet gateway that you created in the previous step. So let's continue with this task 2, creating a bastion host. So in order to create a bastion host, let's go to EC2. Let's open this in a new tab. So EC2. So now we need to create an EC2 instance inside this public subnet. So we don't have any instances. Let's create a new instance. The name should be bastion host. So we need to follow the same name, okay? Otherwise we'll not be having a grade here. Bastion host, and it should be having Amazon Linux 203 AMI. So it's having this, and then it's having T2 micro instance type. So we need to choose voc key, and then we need to update the network setting. So we need to place it inside the lab VPC, and it should be inside the public subnet. So let's choose a lab VPC, and we have this public subnet, and we need to create a security group. So security group will be basically this name. So let's say this, let's say this, let's remove this, let's add a security group rule. It should be SSH, and then it should be my IP. That means I should be able to SSH into this machine. So I've used this voc key pair. So let's go and launch instances. So the instance is successfully created. Let's go to view all instances. So while the instance is being created, let's continue with the lab. So let's go to task 3. So now we need to allocate an elastic IP address for the bastion host. So to do that, we need to go to elastic IP, allocate elastic IP address, and let's allocate. So once we allocate it, we need to attach it to the bastion host instance. Let's associate it. So now if I go to this instances and choose this instance, so I should have this public IPv4 address. So now let's test this connection. In order to test the connection, let's go to detail, let's go to show, and let's download the PEM file. So we can download the PEM file. It should be lab user. I've used this AWS folder. Let's close this, and let's copy this public IPv4 address. So before that, like you can see, I have this lab user PEM file here. So we need to say chmod 400 labuser.pem, and now what I can do is ssh -i labuser.pem, and inside this ec2-user@ this IP address. Let's say yes. So after this, I should be able to connect to the instance, to the bastion host instance. So basically this is the bastion host instance. So we're able to connect the connection. So now let's continue with task 5. So now we need to create a private subnet. Let's go and create a subnet. Let's go to subnets. Let's create subnet. It should be inside lab VPC. The name should be private subnet. The availability zone should be same as the public subnet. So what we have chosen there was US East 1A. Let's add the CIDR block. CIDR block. And let's create a subnet. So now I've created a private subnet. So in order to do this, any machine inside this, if they want internet access, so they need to have a net gateway, right? So now let's create a net gateway. Let's go to net gateway. Let's create a net gateway. So let's choose this lab net gateway. Lab net gateway. And then we need to choose inside this public subnet. And then you can see we need to have our net gateway need to have an elastic IP address. We can say allocate IP address, elastic IP, and let's create a net gateway. So after that, we need to add this net gateway to a route table. So let's create a new route table with this configuration. Let's go to VPC, let's go to route tables. Let's create a new route table. So it will be public route table. It will be for this lab VPC, and let's create a route table. And now we need to edit the routes and then add route. It should be 00, and here I need to pass to the net gateway. So this is a net gateway, lab net gateway, and let's save it. So after creating a route table, so I need to associate this route table. So since a private route table, I need to associate this route table to a subnet. So let's associate it with the private subnet, and let's save. So I think we need to do the same with our public route table. So it doesn't have any subnet. Let's edit subnet association. Let's say public subnet and let's submit. So our public route table is in this subnet, public subnet, and then private route table is in this private route subnet. So let's continue with task number 7, creating an EC2 instance in the private subnet. So to do that, let's also we need to make we should note that we need to create a new key. Let's continue. Let's create a new instance in the name of private instance. Let's go to instances, launch instance, private instance. It should be Amazon Linux 203 AMI. It should be T2 micro. That's all okay. And then we need to create a new key pair. Let's see if I can create a key 2. Yes, I can create. Let's create a pair and let's download it. And let's use this voc2 here, voc2, and let's edit the network setting. So since it's a private instance, we need to create inside a private subnet of the lab VPC. So let's choose lab VPC. It should be private subnet, and then let's choose the existing security group, and let's choose Bastion host SG, and let's launch the instance. So now we've successfully launched the instance. So let's continue with the model with the task. So we need to configure our SSH client for SSH pass-through. So since I'm a Mac user, let's go to this point 29. So I need to do SSH add key voc key pam. So let's do this here. So you can see I have this voc key 2 here. So I have to do chmod 400 for this voc 2 pam, and now I can run this one. And let's do the same for lab user. So after adding this, so I can go to the SSH to my Bastion host. So this is my Bastion host. So now what I can do here is SSH ec2-user@. So let's copy the private IP of this instance, and let's go to the instance. So now you can see we are inside the private instance. So this way we are able to connect to the private instance from the Bastion host. So let's continue. So let's test the SSH connection from the Bastion host. So I need to connect to the private instance by using the SSH. So let's ping, because we have added the net gateway to the private subnet. So we're in the private subnet. Let's say ping 888. So it's showing. I'll also ping Pratap sharma.io. So it should give me response. It's correct. So we're having access to the internet from the private instance. So now the architecture looks something like this. We have an internet gateway. We are attaching the internet gateway to this public subnet, and then we have a net gateway in the public subnet, and then we add this routing policy to this private subnet, so it will connect to internet using this net gateway. So let's go to challenge 2, adding a protection. So task 10, we need to create a network SCL. Let's go to VPC. Let's create a network SCL. It's here. So let's create a network SCL. So before that, I think we need to go through this default network SCL. So here what we can see in bound rule. So we have allow all and we have denied all. The same with this one. So this is a default. Let's create a new SCL. So like we have seen like what it's associated with the network SCL. So let's create a custom network SCL. So it should be, the name should be lab network SCL. So let's give a name this one. Let's choose lab VPC and let's create a network SCL. So the default inbound and outbound rules of the custom network SCL deny all traffic, right? So now we need to configure our custom network SCL to allow all traffic that goes in and out of the private subnet. So let's go to our custom NSCL. So where is that? It's here. So let's go here. Let's add the inbound rule. Let's edit the rule. So we need to add 100, and it should be all traffic. Like we need to configure the custom network SL to allow all traffic that goes in and out. So we need to allow all. Let's say allow, and let's save. Let's do the same with the outbound rules. Let's edit the outbound rule. Let's add new rule. Let's say 100 and all traffic, allow. Let's save change. So now we have modified. So now we need to test our custom network SEL. So we need to create an EC2 instance in the private subnet of the lab VPC. So let's create a new instance. So now we'll be creating a new instance inside a public subnet. So let's copy the name of this instance. Test instance. The AMI should be same. It should be T2 micro. And let's choose here VOC key. And here I need to allow all ICMP PV4 inbound traffic to the instance through the security group. Okay. So in this case, let's say edit. Let's say lab VPC. So it should be in the public subnet. That sounds good. So now let's create a security group, test SG. Let's do the same in the description. And here what we have to do is we need to allow all ICMP IPv4 inbound traffic to the instance through the security group. So let's do that. Let's remove this. Let's add a new group rule. So it should be all ICMP IPv4, and then inbound traffic instance through the security group. So let's say all, it should be all, anywhere, and then I think we can launch the instance. Okay, so let's go to all instances. So basically we have so ignore about this instance, I don't know why it's terminated. So we have 3 instances: bastion host, private instance, and test instance. So this is our new instance. So now we need to know the private IP of the test instance. Let's copy the private IP of this test instance. So to do that, let's go to here. So this is the private IP address. So now what we have to do is we need to test that we can reach the private IP address of the test instance from the private instance. So basically this is the private instance. So let's say if I say ping 78, so that means I'm able to get access to that test instance. Okay, and let's, okay, they are saying I need to let the ping running. So let's leave it like this, and let's continue. So now I need to modify the custom network SCL to deny all ICMP traffic to the private instance. So how will we do that? So this is network. So before that, I need to edit this subnet association. Before that, like, let me just update the inbound rule. Let's edit rule. So what it's asking me is, it's asking me to deny all ICMP IPv4 traffic to this IP address. So it's asking me to deny. So let's go to this one. So if I want to add, I need to add a rule. So it should, if I want to deny, and like if you read this note, so make sure that this rule is evaluated first. Okay. So to do that, I need to make sure that my rule is 99. It will be executed first, and it should be custom all ICMP IPv4, and here I need to put the private address of this private IP of this test instance /32, and then I need to deny. So if you can see, so it says that I need to deny all ICMP traffic to this instance. Okay, so let's save it. So now I need to associate this network SCL with the subnet. Let's associate it. So it should be with the private subnet. Let's save. And now you see that it stopped getting now it doesn't get any internet access to this. So as you can see in the private instance terminal window, the ping command should stop responding. The traffic to the test instance has been blocked. So you can see like we don't have any traffic. So that means the traffic to test instance has been blocked. So this way we can we can add an extra layer of security. So after completing all these labs, I think our architecture looked something like this. We have a default network access control list in this public subnet. We have a custom network access control list in this private subnet. We have internet gateway attached to this public subnet. So far our lab looks something like this. So let's answer these questions. Let's go to show. Let's access the multiple choice questions. So what is the purpose of the internet gateway in the public subnet? So I think here the answer should be allows the public subnet with the public IP address to communicate with the internet. So what allows the instance in the private subnet to connect to the internet? So it should be net gateway, because when we add a net gateway in the public subnet, the private subnet will be able to access the internet. So can the instance in the private subnet be accessed directly from the internet? No, it should not be. So why do you use two different key pairs to access the private instance of the best-in host? So the answer should be like separate key pairs could reduce the impact of compromised best-in host. And then can the best-in host use ping and get a reply from the instance in the private subnet? This should be no. So when security group rules allow which security group allows the private EC2 instance to receive the return traffic when it pings the test instance? It should be outbound on private and inbound on test. So these are the answers. So let's submit. And let's also submit the lab. So here, so in this lab, I've scored 98.21 grade. So I think this is it from this challenge lab. Hope to see you in another guided lab or challenge lab or knowledge check. Till then, keep watching.